You want solar imagery? We've got your solar imagery right here. So, I'm really mad about it. That's what's been going on with the sun for the past 24 hours. We'll show you that and lots more tonight at the Daily Space Weather Show. That's imagery from today, January 12th. And yes, the hair has no product in it. None! No, I'm not sharing how it is done. Here's some more imagery of the sun. And what about if we show even some more imagery of the sun? How about that? How about that? That okay with ya? All right, well, thanks. That's today. That's also today. The colorized magnetogram. It's making me so mad. Why are there so many sunspots? Let's calm down and look at volcanoes. All right. So those are the erupting volcanoes at the moment. And let's see what's going on here. Any volcanoes are going to trigger me. Let's see if we can see what's happening here. Grimsvötn has likely caused some kind of a glacial outburst flow that hasn't happened since a couple years or something. Glacial flow! Great glacial flow! A wintertime glacial flow happening in Iceland. Oh, it makes me so mad. Some people think I should take anger management, which also really pisses me off. All right, anyway. These are the other volcanoes that are erupting. I'd read them off to you, but reading really irks me. It's one of my pet peeves. What if I have to read a newspaper about how your soul was immersed into the river Styx? What about that? How about that? Anyway, those are the volcanoes. Here are the earthquakes. That's the past 90 days. Largest quake of the past 24 was off the coast of Alaska. If I were in Juneau and I felt that quake, I would be absolutely enraged. I would be enraged. What about you? Let us know in the comments if you felt this 5.9. Maybe you were at Sarah Palin's place. Mariana Islands had a 5.0. Guam. No, Greece had a 5.0, not Guam. That 5.9 was at 7:46 this morning. Did it cause a tsunami? Well, not likely. Mid-Atlantic Ridge had a 5.0 in the Tropic of Capricorn. Peru had a 5.3. And those are the 5 and greater magnitude quakes for the past 24 hours. By the way, don't forget to press the subscribe button if you're new to the channel. If you don't, I will sleep well tonight, not caring. However, if you do not press like, your soul will be sought out, and your soul may end up in the soul of a dog's doghouse soul attic in dog heaven. Is that what you want? You want your soul mothballed in some rickety old dog's house in the attic of your soul, the dog's soul's doghouse? That's not what you want. So press like. Otherwise, those things could happen. The radio flux is at 186. There's the 1 year graph of the radio flux. Ta-da! It's not at 190. It's going to come down by tomorrow at 186. So anyway, there's the space weather enthusiasts dashboard. And they're not forecasting any geomagnetic storms or geomagnetic unrest, and we have quite calm conditions. So there you go. And by the way, these calm conditions are really starting to just eat away at my patience, eating away, like Kramer unable to become a banker on Seinfeld. And it's just starting to really just eat away at your soul because you've still forgotten to press the like button. How dare you? Anyway, here's Earth's magnetic moment from the ground level. Ta-da! And again, it's geomagnetically calm, so there will be some aurora in some places, probably, but not like real extreme ones. So that's what's going on. KP index is at KP1. Not too exciting. Solar wind at the ACE spacecraft is non-existent, so hopefully it hasn't been destroyed by Nibiru, by the spooky galaxy, or by aliens. But if you put in ACE and you click OK, you get a blank screen that says Discover. So let's look at the actual Discover data. There's the actual data, and Discover showing 5.5 protons per cubic centimeter and about 460 kilometers a second. So a little bit of a variable solar wind here, going between about 500 kilometers a second and about all the way down to, I don't know, 450, 460 something. So yeah, that's the solar wind situation from the Discover solar wind station. GOES magnetometers are pretty smooth as well. No space weather. The top view, look at the plane field plot is next. So here it is. Earth remains in a North Pole oriented magnetic heliosphere sector. There's the latest image. Here's our line of sight field plot. And if you've noticed, I'm speeding things up today because our Ask a Physicist segment is 12 minutes long. So anyway, there's the solar B field in blue, the polar fields in green and red, and the photosphere magnetism. That's where sunspots occur in grayscale. Last but not least, the line of sight coronal hole plot. Lots of North Pole coronal holes. Not surprising, as Earth is in a North Pole sector, so there you go. Coronal holes on the Earth side of the disk. Here are, oh, check it out. We've got some more imagery here. And it makes me so mad when I don't remember to show you certain imagery. It just, oh, I just can't take it. It makes me want to smash stuff. I mean, just forget that part. So this is a 48-hour video, actually. Yeah, 48-hour video of 211 angstroms from SDO. That's coronal holes. And there is one there rotating in. It is undoubtedly of North Pole orientation, as you can see here. So yeah, North Pole coronal hole rolling in. It might cause some mild space weather there for a little while. Fingers crossed for that. And before we get to sunspots, let's look at some more sunspot stats. Sunspot number is about 190. So, oh, and I almost forgot. If any sociopath is telling you that the sun is shutting down or that the galaxy is going to kill you, we'll get to that here in a minute. Sunspot number is at about 190. 190. So we're still getting comments, people asking, is the sun shutting down? I've joined a cult and I haven't looked out for years. Now, we told these people back in 2018 and 2019 that you can't declare a grand solar minimum until you have 2 weak solar cycles in a row. Did they listen? What do you think? Did they listen? Just leave us a comment. Let us know what you think. Let us know if you think the cult high priests listened to us when we said you need 2 in a row for a GSM. Let's move on to talk about Oppenheimer Ranch Project's cult high priest diamond. First of all, Oppenheimer Ranch Project, I refer to him as Talc because I find him greasy, soft, and carcinogenic, keeps telling people that it's a grand solar minimum. Zarkova's original forecast was not representative of reality. Her revised forecast was also not representative of reality. For some reason, this charlatan keeps flapping his lips about a grand solar minimum. He says it every day as his cultists hear the chant, and I guess they stay in the religion even though it doesn't represent reality. All cults, they have a living leader, they're harmful, and they believe nonsense. Sound familiar? speaking of nonsense, here's another nonsense artist channel known as Suspicious Observers. Ben Davidson was talking about a grand solar minimum. It was part of his spooky catastrophe theory up until about 2 years ago, when it mysteriously vanished, as he still continues to gaslight his viewers and suggest that he's ever forecasted anything or published an actual science paper. So, at least one that makes any sense or passes peer review, as if that's relevant. So, anyway, if you're wondering which charlatan is sillier, neither should be taken seriously at all. Not Talc over at Oppenheimer Ranch Project, and not Ben over there at Suspicious Observers. These are not serious people. These are cult leaders. Come out of the woodwork, guys. Reality is right before you. Please, try to enter it, and it's pretty pathetic. What's not pathetic is Mr. Eugene Bagashov. So we're delighted to have another Ask a Particle Physicist segment tonight. So we'll be airing that here in a minute. It's part of the reason I've been speeding up the video until now. So, but make sure you go over there to Eugene the Philosopher. That's with a Philostopher. And a lot of awesome videos over there. While I don't agree with everything he says, China is indeed an overrated paper tiger. I've said it many times on the channel. So anyway, go check out the videos. Science, it's not a worldview. Okay? So, yeah, some great videos over there. So, without further ado, let's get to our Ask a Particle Physicist segment. Take it away, Eugene, the Philosopher.
All right, today's question is, would you please define and explain what each lines of this graph represents, each of the lines? We're talking about this graph, even though it's already a smooth one, so I guess it would be more helpful to examine the source, this one. Right? So, what do we see here is the solar polar fields. And what are these exactly? Well, let's go to the website, see what they say. So, essentially, we're observing like the uppermost, 25 degrees of the sun. So we look at the sun, and we look at the top 25 degrees in terms of latitude. Okay, so 25 the furthest from the equator, or 25 the closest to the pole, if you wish, to the pole as we see it from Earth, that is. And I'm going to explain that a little bit later, what's the difference. So we look at the north, and we graph like how strong is the field in the north. Okay, and this is what we all right, maybe this graph is more helpful actually. So we look at the north, and we see this blue line. It's the polar field north, you see. So when it's maximum, so what does it mean? It means we're counting when we're looking at the sun, and we use like magnetic whatever data. We look at the sun optically, but we like imply the magnetic field somehow through some methods. I don't know, I'm not a heliophysicist. And we're counting essentially how many field lines exit the sun. Okay, so this is the definition of the north polarities, the lines of field lines exiting the sun. And I repeat, we only observe the top 25 degrees, and this is represented by this blue line. All right. So when there's a lot of north polarity lines exiting the North Pole, we have the maximum of the north polarity, which happened around October 3rd, 2019, or something like that. October 2019, maybe September actually. This corresponds to, I guess, somewhere here. Wait, might be completely delusional. Maybe somewhere here, actually. I don't know. No, let's look at this one. It's easier to analyze. Yeah. So when we see almost no lines of force, magnetic field lines, exiting here in this section, right? we observe 0. We say it's the blue line is at 0 then, which last time, actually it's like kind of happening right now, but before that, the last time it was 2013, 2012, something like that. All right, and vice versa, like when the blue line is here, it means the lines of force are exiting here from the south, right? Likewise, we observed like the bottommost 25 degrees in terms of latitude. And if the field lines exit there, then we say, okay, the north polarity is sort of in the negative. It's like, it's magnetic north, but it's now in the south. Okay, so the lines of force exit from the south, and there's a lot of them, so we have a maximum in terms of, like,
It's very good.
the number. It's negative, but the number is big. Okay, and we again rewind the time backwards. We arrive at this point where in the south, basically no field lines were exiting the sun. And vice versa, the red line, it's showing where the lines enter the sun, or rather how many lines enter the sun in these polar areas. If a lot of lines enter the sun in the south, we get this, right? The red is highly negative, so to speak. When there's basically no lines exiting the sun, entering the sun, I'm sorry, in the south, we get 0 of the red line. And when there's a lot of lines entering the sun in the north, we get positive red line, if that makes sense. So long story short, this picture, when blue is very positive, red is very negative, it means the sun is basically like a dipole. So the lines exit the north, enter the south. Okay, when we're at 0, it means that the poles are kind of empty of fields, both of poles. So all the magnetic field lines like are exiting and entering somewhere near the equator, on either side of the sun. I mean, obviously it rotates, etc., etc., but it doesn't interest us very much. And vice versa, when you have highly negative north, highly positive south, it means the lines are exiting south and entering north, which is the opposite polarity to this cycle, for example. Actually, like, we're gonna observe that, like, the next minimum would be exactly that. The north will migrate to the south, and the lines would start exiting from the south in the next minimum and entering in the north. That's what will happen in the next minimum. There's a parameter called A, I think, like a capital A, and when it's positive, like, the lines exit north and enter south. So heliographic poles and magnetic poles are of the same, polarity, you might say. And when A is negative, it's vice versa. So we're exiting positive A phase, where we've peaked in 2019 roughly, during the last minimum, and we're entering the negative A phase during the next minimum in 2029, something like that, 2030 maybe. Yeah. All right, so let's look at the original still, because you can see there's some interesting stuff going on. Like, why is it oscillating like crazy? Well, it's actually because, okay, let's re-examine. These are smooth graphs, okay? What do I mean by smooth? Well, they're filtered by 20 nanohertz, and they're saying the same here. Wait, let me see it. 20 nanohertz low pass filter. What does that mean? What is 20 nanohertz? Well, it's roughly once every 1.5 years, something like that. So we kind of ignore short scale oscillations and we kind of smooth it out temporally, okay? And once every 1.5 years allows us to get rid of this yearly oscillation. So this oscillation is due to Earth's orbit, because these guys are looking at the sun from Earth, and the Earth's orbit is like, imagine this is the solar equator. It's actually not, because this picture is also taken from Earth, but imagine it is, and our orbit is tilted with respect to the solar equator. So in spring, we're actually up above the solar equator, so we see the north really well. We see like this kind of section of the sun, with a lot of north poles being visible and not a lot of south pole being visible. And half a year later, in September, we're below the solar equator, So we see a lot of South Pole. I'm sorry, it's vice versa actually. No, it's correct. Yeah. In September we see a lot of South Pole and not a lot of North Pole. That's why in September, like the southern pole would be artificially stronger, if you wish, like stronger than it should have been in our observations. So you can see like the last peak this autumn, right? September, October. So the south was peaking and the north was falling, right? I mean, it should be vice versa. Actually, I don't really remember, to be honest. Wait, let me think about it. No, in September we're here. Yes, in September we're up above the equator. Never mind. In September we should see stronger fields in the north. And in March we should see the southern pole. Yeah. So this one was September. So, well, whatever was happening here, this peak is caused by it, okay? And the same thing goes on every year. So if you filter this with a 1.5 year period, essentially, you get rid of this oscillation, more or less. I mean, of course, like some traces of it remains, as you can see here. But you get this smooth curve. Okay, so this is the smooth curve. Or rather, look, this black one. So these are individual north and south, just as we've discussed at the beginning, the blue and the red. But they've taken in, well, it's kind of out of phase with respect to this one. You can see that here they're like, inverted, and here they're in the same sense. So it's just the strength, right? But nevertheless, what I was saying is that this black line, which also oscillates, is the average. You can see it. So we take north value minus south value, and we divide it by 2. We get this oscillating part, but which is kind of signless now, if you know what I mean. Just indicates the asymmetry, if you wish. And at the same time, it indicates kind of the absolute value of the field overall, of the overall field, if you wish. And if you smooth it with this filter of 20 nanohertz, you get this sort of more calm curve, right? And this is what they're showing here. They're only showing the averaged curves. Here we have only one averaged curve, not averaged but filtered, like smoothed out. There's only one curve smoothed out, and here they artificially take the numerical data from this website. You can see it here. And they take the average of the south, the average of the north, and the average of their difference. You see north minus south, which indicates kind of the field strength overall, plus the polarity. All right. So here we have north in the north, south in the south. Here we had vice versa, so that's why it's negative, right? The black line. All right, hopefully that explains something. I know it was a bit confusing, and I was confused during this when I was trying to explain the Earth's orbit, but eventually I got it right, I think. In autumn, in September, we're above the solar equator, so we see more of the North Pole. That's why here more lines would be like visible, exiting or entering the polar area proper. That's why we get this weird oscillation with 1 year period. And in March, April, we're like below the equator, so we see more of the South Pole, and so it's also going to be like distorted, north versus south, like it would get a boost in its asymmetry, whereas it shouldn't have. So if you get this filter, you get rid of this oscillation. So this data is not very reliable in this sense, right? It's kind of skewed a little bit, but if you look at it at the bigger picture, you can see what's going on. So the field reversal, when the poles are basically the entering or exiting lines are absent at the poles, these are basically the solar maximums, and as you can see here, we're right in the middle of one right now. All right.
So there you have it. I know it's a bit complicated, and it's, there's a lot of different things going on there, and there's some perhaps counterintuitive stuff happening, right? So, I just wanted to be aware of that. And again, thanks to Eugene. Make sure you go subscribe to his channel over there at Eugene the Philosopher. The URL is... Oh, he's also got a Patreon. You know, you can help him out there. So cheers. That is what's going on with that solar polar field stuff. And let's get to some more actual data points here. So flare probability still is very high, just like it was yesterday. We have multiple spots that are looking very unstable. In fact, there's a coronal mass ejection happening as we make the video. Down there in the lower left, right down in here, there is some plasma blasting off, and there's a bunch of instability around the eastern limb in general. We've also got a bunch of active regions setting on the western limb, so lots of stuff going on. The proton flux is still flatlined here, no relativistic particles. Background X-ray flux is about a C1.6. No major flares in the past 24. Here come sunspots and flares from SDO. So there are sunspots, and let's actually zoom in a little bit here. So that's what approximately 190 sunspots looks like. And here is, we'll also show the 1600 angstroms wavelength, ionized carbon. And here's one of our favorite flare wavelengths. Now keep in mind it's not actually X-rays, but it's just good at viewing flares. It takes 10 images per minute instead of only 2, so 131 angstroms is always a class act, and you'll see that on lots of thumbnails and photographs shared on Twitter or things like that. Not half bad. And let's get to some more stats here. That's what's going on overhead at the moment. There's our star chart from skyandtelescope.org. You've got Saturn and Jupiter overhead right now, Lehigh Valley, Pennsylvania. Also, you can see Betelgeuse, so the largest planet and the largest single object visible to the naked eye, the star Betelgeuse, in the constellation Orion, right where I can't quite touch it, right there. Next, the solar system forecast. So this is where things are today. Here's your 1 week forecast for heavenly bodies. And by the way, once again, happy new moon, my favorite phase. Shout out to all my reverse werewolves out there who understand why a new moon equals reverse werewolf. Here is our sup with that. It's apod.nasa.gov's astronomy photo of the day. From Rheinland-Pfalz, Deutschland. A great view of Mercury, Venus, and the morning crescent moon up there. Something you get just after new moon. You might see a very bright Venus out in the morning skies right now. I actually checked it out just this morning. So there you go, Venus, Mercury, and the crescent moon, all visible there if you've got the right kind of conditions and a low enough horizon. Moving to coronal mass ejections. And by the way, thanks for tuning into the Smash News Network, least busted name in news. Have I calmed down? Am I still mad? Oh yeah, I'm still mad. I'm still ready to just freak out and lose my you-know-what over CMEs. Why? Because they're not earthly directed. That's why. Those are just fine. Fingers crossed for some Earth-directed CMEs coming soon. So there's some more information, and yeah, we've got... There was a significant event on the far side of the sun. It caused a ripple to cross the entire surface of the closest star, or at least a significant portion of it. But that was likely a large flare and a likely large coronal mass ejection on the far side of the sun, or at least out of view. Maybe behind the eastern limb there is certainly quite a bit of activity about to rise over the east. So, but that's what's going on for coronagraphs. Things are pretty chill for CMEs. Next, we'll go to filaments. And the Cerro Tololo ground-based solar observatory there showing quite a bit of filamentary material there in between Earth and Sun. Here's perhaps a better view. We show the grayscale because it shows prominences, which are not shown in the colored imagery. And you can see a number of prominences there in the east. Like I said, multiple new sunspots likely to be rising soon in the next couple of days. So also a lot of dark absorption features there. Those are plasma filaments largely. Dark absorption features where there is less 6,562.8 angstroms electromagnetic radiation. Cerro Tololo, Chile, folks. And we got a crown prominence going on once again, so check it out. There's a great crown prominence right there in the northern polar region. That's the past couple of hours there from the GO 16 SUVI. Today on January 12th, 2023. So that ends at 2300 right there. So that's about 2000 through 2300 or so. About 2.5 hours, I think, is actually what that is. Nice CME going off there. And let's get to bonus features before we get to our meteorology segment. So bonus features, charging hazards. We don't have them. It's smooth sailing for satellites. Next goes electron flux. Coming up off the floor here. So a little increase in the electron flux finally. And there it is. A little tiny increase. Nice. There's the forecast, and it looks like NOAA is expecting an increase in the electron flux. Bring on those electrons. Next, we'll show the layer where it's measured. The F layer, folks. The F layer. Don't be effed. Know your ionospheric layers. The D layer is down here. And then you've got the E layer, and then you've got the F layer. Don't be effed. Know your F ionosphere. It's at about 300 kilometers of altitude. And yeah, it's pretty uneventful. Here's the anomalygram. Also pretty uneventful. There is nothing to be spooked of in the ionosphere map. We're terribly sorry if you were wishing for the apocalypse. Still not scheduled. No matter how many cult leaders tell you the apocalypse is on the forefront, just not scheduled. Next is the wham, which is not a careless whisper on the space weather. When the music dies, people are high on hallucinogenic drugs, suffering from delusions. Anyway, that's the ionosphere. And yeah, it's just fine. And here's the closest star, and it's got like 190 sunspots on it. So hopefully that's not making you mad. And I've said it before, I'll have to say it again, I'm sure. If each sunspot that forms makes you mad, consider psychiatric help. You might have lost your you-know-what if you are mad about sunspots. So let's move on to some Earth activity, shall we? First, we'll show surface winds. Then we'll show jet streams. So there you go. Jet streams. More jet streams. More surface winds. More surface winds. and more jet streams. Clouds and fog. Clouds and fog closer up, since there is a strong low pressure zone right over Chicago, the Windy City. Shout out to our viewers from Chicago, the Windy City. A place which right now kind of sucks because there's a low, and if there was high pressure over it, then it would blow. But it's a windy city nonetheless. Those winds induced by suction, not blowage. Anyway, there it is. You can see a bunch of roads pointing to Rome, if Rome is Chicago, otherwise known as Chicago. And there it is. That is largely affecting U.S. weather. We've also got this massive high pressure making its way down from Canada. Why is it such high pressure? Because it's extremely cold air. And Montana is, look at the temperatures. The temperatures are absolutely berserk in Montana. Look at that. How about negative 30 Fahrenheit? That's on the cool side, I would say. Negative 30 Fahrenheit there in Montana. So here are your weather warnings, and yeah, that's a lot of weather warnings, once again. That's a lot of weather warnings, folks. So, dag. Let's show the key. Watch this. Dag. Well, the U.S. was due, and it's getting some weather. Fortunately, U.S. citizens are pretty adaptive. Yes, I know, many are sheeple. I know you know so many sheeple. However, people in the U.S. have powers which will not be disclosed in this video. Known unknowns and unknown unknowns and known knowns. Next, let's get to some forecasts. We're only showing one today because shortening the video so it's an appropriate length. Here's your GFS 72-hour pressure and precipitation forecast. Keep your eyes on those pressure lines, as well as those ice storms. Ice storms coming to Oklahoma and Texas, not optimal. Be prepared for those. Here's lightning. That is for a long time. That's like 10 hours of lightning. And here is a real-time lightning map. We do have some minor terrestrial strikes going on here, just west of Raleigh. There are some lightning strikes here south of Greensboro. There's our full lightning map. And things are pretty calm here. Not a lot of lightning here on planet Earth at the moment. Only 33 strikes per minute, at least as recorded and reported by lightningmaps.org. We'll close out with U.S. Doppler radar. Clouds and fog. And water vapor. When your Doppler's unclear, use the water vapor map. Highly recommended. Here's your recap. We hope you got offended. We hope that your gut and colon are not distended. And we hope that all the criminals finally get apprehended. Recap complete with the water vapor map. See you soon. Hopefully you're not consuming crap on YouTube. Bye. Back to the bunker. Whoa.